Welcome back everybody for part 3 of the 3.2 notes where we're talking about polynomials. And we saw by now a couple of things about polynomials, especially we've seen standard form. There's another form of a polynomial that's actually possible to write, and it could probably be called maybe the factored form, because it is possible for every polynomial that there is in the whole world to factor it into, in fact, it's possible to factor it into linear factors, not just factors period, but linear factors that are based on the roots. And so, for example, this would be a form for our quadratic because there are two terms that have x in there, and if we FOIL this thing, we would end up having the term that goes x squared. And so this one has two roots because roots, we understand, is the same thing as zeros. These are zeros. Also, that's the same thing as x-intercepts, which all of these things mean solutions to this kind of an equation, f of x equals 0. That's why they're called zeros. And so these terms are all identical and interchangeable. And if we wanted to find the zeros of this kind of a function right here, what you do is you just set it equal to 0. And then we don't really need this term that would be the coefficient for the x squared term because we can just divide both sides by a. It's no problem. So this term in this kind of a coefficient in the front doesn't really matter. This side will still just go 0 is x minus r1 and x minus r2. Where here, the two zeros, that's why I'm calling them r, because they are roots. And so r is in root. We would get, for this one, we just set each one of these terms equal to 0 independently, and we just say x minus r1 is 0, or x minus r2 is 0. And then these ones we can solve them. It goes like x is r1 or x is equal to r2. And so the two roots just end up being root 1 and root 2, which is what we started out with in the first place. We kind of started out with the idea that the roots were root 1 and root 2. But anyways, that's how we would find it. We need to first, if we're given, for example, like this problem, we're given a polynomial that's in standard form. We're wanting to discuss the zeros. And the zeros of this one, we need to first factor this. And there's one main factoring technique that we would use whenever there are four terms, which is that we will factor this one by grouping. And so what we would want to do is we want to kind of group the first two terms, and then we want to group the second two terms, but it's very tricky how there's this minus right here. And so what I would want to do is go plus, and then actually the 16 is negative. Is what we're basically dealing with. We're dealing with the terms x cubed minus 5x squared, and then instead of the minus it becomes a plus, and then that parentheses is coming in there. The minus 16 actually is the same thing as plus negative 16. And so I'm wanting to just be very careful what happens with this negative sign over here. And then out of the first term we can factor out x squared. So it goes x minus 5. Out of the second term we can factor out, these are both divisible actually by negative 16, so we factor out the negative 16, and it will go x, and then 80 divided by negative 16 is negative 5. So x minus 5. And then we're able to factor out of this whole thing, where we have basically two terms. We have this term over here, and we have this term over here. They both have a factor of x minus 5, so we can factor out x minus 5. And what it leaves is the x squared, and then minus 16. And then we're in a situation where we actually have more that we can factor here, because x squared minus 16, it's a difference of squares, and so we can factor this thing like x plus 4 and x minus 4. And then it has, of course, x minus 5 in the front. And so this whole thing, the f of x, we can write it into a factored form this way. And so the zeros are, I'm going to give myself some space there. The zeros are x equals 5, and also 4, and also negative 4. There are three zeros. Now, this one worked out that all the three zeros were different, but there's a complication because we should have for a polynomial that the number of zeros is the same as the degree. But it's not necessary that those zeros are different. And so whenever one zero, or in this case if we have a factored form and an identical factor appears more than once, then we call this term the multiplicity of the zero. And so for example, we're given a factored form over here. If we're trying to find the zeros, we would just set it equal to 0. And then for the same reason as we saw before, we don't have to worry about this 8 because we can just divide both sides by 8. And the 8 would just cancel, it just goes away. And then we need to set each one of these factors equal to 0. But the factor x minus 1, it appears twice because x minus 1 squared actually means x minus 1 times x minus 1. And then x plus 3 cubed, it means x plus 3 times itself 3 times. And so if we come in here and do it 3 times, then this really would be the kind of factored form that we're looking at where it's just these individual factors like this. We see though that it's possible to rewrite it by putting some powers there. If the same factor appears more than once, then we just write it once and then we put it to some power. So that's convenient. But here if we wanted to set these all equal to 0, some of them happen more than once, and so that's what we use this term multiplicity for, is we will say that one of the zeros just comes from this term, the x equals 0, that works. Also x minus 1 should be 0, so that means that whenever x is 1, that's also another 0. But here we should add on to this one that x equals 1 is a 0 with multiplicity, and here we say how many times this same factor appeared, which it was there twice, so multiplicity of 2. And then because of these terms over here, we have that x plus 3 equals 0 gives us that negative 3 is also a 0, but this one appeared 3 times, and so we would write that x equals negative 3 has a multiplicity of 3. And these would be the zeros with the multiplicity. So this one that only appeared once, we could say that it has multiplicity of 1. And so 0 with a multiplicity of 1, 1 with a multiplicity of 2, and then negative 3 with a multiplicity of 3. Those are the zeros with the multiplicities. And we will talk about coming up what we can do with these multiplicities, what it means for the shape of the graph, and things like that. So thank you guys for watching, and catch you in the next video.